Hello and welcome back. We're going to go over some of the basics for graphing. Now this is in addition to the other videos that I have, and it's in addition to the outline in the textbook. And just in case you kind of need a little bit more, you need a refresher, you might not really, but in case you do, here we go. So there are three relationships in economics. There's a direct relationship, here's the first one. There is an inverse relationship, and then there are independent relationships. Now, nobody's going to bother to necessarily graph an independent relationship on its own. It's just that sometimes a graph has multiple curves and some of them might be independent. Now, the first one we're going to look at is a direct relationship. I will remind you that it's important to pay attention to what the question is asking, and unless you kind of slow down and focus on what the concept is, you might miss the question altogether. So if somebody asks you, what is the relationship between these two variables, x and y, the minute you hear what is this relationship, you're basically going to be saying it's direct, it's inverse, or it's independent. So in this case, it is actually direct. What does that mean? It means you have x impacting y directly. They have a positive relationship. If x goes up, so does y. If x goes down, so does y. So in this case, we're looking at the number of bakers per day and the number of loaves that they actually bake. And you can clearly see that the more bakers are baking, the more bread is going to be baked, but then eventually that's going to slow down a little bit. This actually has to do with the law of increasing opportunity cost. This is something you will see in chapter 2, which basically shows you that eventually the return begins to shrink in such a way that the trade-off becomes more expensive. But anyway, that's besides the point. So what we're seeing here is more bakers, more loaves of bread, right? And this is a table. Now in the homework for the graphs and in the homework for chapter 3, you will have tables to translate into graphs. It's really as simple as this one. You're just following it, right? When it is 6 bakers, you're looking at a total of 1,075. See, 6 bakers, a total of 1,075 loaves. But maybe when it is only 1 baker, it is 400 loaves, and it's right here, 1 baker, 400 loaves. This is all you're doing. And these are the points plotted, and then once you connect them, you actually have a curve. So when I talk to you about movement along a curve, and I'm talking to you about points on a curve, they are all on the same curves. That's what makes a curve, a bunch of points that you actually link together. This is a direct relationship. We're now looking at the slope for the direct relationship. The slope basically is looking at what the change in y is and dividing it by the change in x. When the time comes, these lessons will kind of come back, but for now, let's just take a look at this one for a minute. So why does it say here going from E to F has a slope of 50? Because what is the change here on y from E to F? It's 50 loaves, from 1,000 to 1,050. What is the change down here on x? From 4 to 5, it's just 1. When you divide 50 by 1, you get a 50. Same thing here, right? So this is saying what's going on here when we go from C to D. Well, when we're going from C to D, then the y is changing by 200 units. It's going from 700 to 900. What is it doing down here? It's still just 1, right? 1 baker. So this is going to be 200 divided by 1. And you will see more of these examples as the time comes. It's really not all that difficult. It's the function of x. You kind of learned that in algebra, but I just wanted to kind of give you an overview on it. Our next relationship is the inverse relationship. So an inverse relationship here, look, it's downsloping rather than upsloping. So you have a curve that descends, it downslopes. And so x impacts y inversely. The relationship is rather negative. When x rises, it causes y to fall and vice versa. Do you notice how I keep saying causes, impacts? X is always in charge, y follows. Don't ever reverse the variables. So what are we seeing here? We're seeing that the bigger x is, the smaller y actually is. So think of this like vacation days and think of the y as stress meter. When you have only just arrived on vacation, your stress level is very high, right? You just left work, probably haven't had vacation for weeks, if not months. You traveled, if you're down in the islands, you were on a bus for an hour. You're exhausted. Your stress level is really high. And look what's happening on day 3. Your stress level has really gone down on day 4. On day 4, your stress level is like what? Like maybe 11 or 12, down significantly from 50. By the end of your vacation, you have almost no stress. And that's because more days, less stress. Fewer days, more stress. So when we first started going on vacations, remember the first vacation my husband and I did, it was 5 days, and he told me it needs to be longer because I feel like I only just got to feel seriously relaxed, and then we have to go back to everything. So this is an inverse relationship. There's also the independent relationships. Notice how I have it as vertical or horizontal. This is vertical. What does vertical mean? It means X is independent from Y. Whatever is happening on X, it doesn't have a connecting point. I'm going to flip back for a second and show you. If you look at these, there's a connecting point, right? So this point here connects the 6th with the 6th day of, like 6th day of vacation with about 9 points of stress. There's a connection. But if we go back to the independent ones, there really is, there's no shared point. So X, the only point that's relevant is right here on the X. Now, as far as horizontal, it means Y is independent from X. Whatever is happening on Y, the only thing that matters is right here at this point. So you might see them in a combination graph. Now, in recap, we are looking at inverse relationships, it's downsloping. Direct relationships, it's upsloping. Independent, in this case, this is a constant, it's constant on Y, right? This one, if you look at the green, it is actually constant on X. So vertical, horizontal, they're independent. Upsloping, it is direct. Downsloping, it is inverse. Sometimes it has a proper curvature. Sometimes it does not. It's linear. Sometimes it's an S shape, which means it can be on the down in one section, but it can be on the up in another section. You will see certain things and different curves, and it will ring a bell and you'll remember. Thank you for sharing these few minutes with me. I appreciate your time. You guys have a great one.